After studying this module, you will be able to 1. Acknowledge the limits that environmental constraints offer to economic growth. 2. Review the ways in which economic activity affects the natural environment. 3. Introduce the concepts of sustainability. 4. Explain the distinction between the concept of weak and strong sustainability. 5th, learn about the importance of substitutions possibilities in ensuring constant consumption opportunities far into the future. Let us now start with an introduction of concept of sustainability and development. Development and sustainability issues have remained at the core of concern for a majority of class of environmental economists. These issues were first highlighted in a book called The Limits to Growth, which held environmental constraints as a significant factor in slowing down of world economic system in the middle of the 21st century. The book received a mixed response from the economists, but was able to stimulate economists' interest in environmental resources. The limits discussed in this book were in terms of 1. The amount of land available for agriculture. 2. The amount of agricultural output producible per unit of land in use. 3. Amount of non-renewable resources available for extraction. 4. The ability of the environment to assimilate wastes arising in production and consumption, which falls as the level of pollution increases. All these proposed limits would result in sudden and uncontrollable decline in both population and industrial output amid unrestricted industrialization and resource extraction. Concerted efforts would then be needed to restore ecological and economic stability that is sustainable far into the future. Thus, it becomes important to explore existing and effective substitutes of environmental services to overcome various limits to growth. Daly in 1987 discussed two aspects of limits to growth. First, the biophysical limits governed by the laws of thermodynamics and other dynamics of ecosystem. The second aspect talks about the will or desirability of growth rather than its feasibility. Daly states the following propositions about limits to growth. 1. The future generations pays the price of current generations' pursuits of growth in terms of depleted stock of resources. 2. Growth is in turn affected by the extinction or reduction in number of non-human species whose habitat is taken over for higher growth rates. 3. The growth of will to grow is usually driven by vested interests and a scientific technocratic worldview. The discussion on limits to growth brings to the fore the interrelationship between economics and environmental sciences, which can be understood with examples of environmental impacts of trade expansion and climate change. Trade expansion does offer economic benefits, and various empirical studies testify that these economic benefits trickle down to elevate living standards of poor people as a group in the society. However, the environment consequences of trade expansion need to be assessed before a case for free trade is proposed on the basis of economic benefits it offers. Poor countries are usually rich in endowment of natural resources like forests or fisheries. Expansion of trade may only mean extraction of these resources at the expense of livelihood of many poor people. For example, timber concessions to private logging firms in order to promote export causes deforestation and in turn leads to increased siltation and risk of floods. The victims are the scattered group of poor farmers and coastal fishermen who are usually not compensated by private logging firms, making the firm's private cost of logging less than the true cost of logging. This reasserts that the environmental impacts of free trade must not be ignored. Climate change is another concern that intertwines the environment and economics. Intergovernmental Panel on Climate Change, that is IPCC, an organization representing mainstream scientific opinion, apprehends climate change to be the result of exploitative human activity. Emission of carbon dioxide, that is CO2, into the atmosphere is one of the most important factors that influence climate change. CO2 absorbs infrared heat at a constant rate and at a higher rate than nitrogen and oxygen, the main constituent parts of the atmosphere. Hence, an increased amount of CO2 in the air leads to warming up of air. According to scientists at IPCC, indiscriminate burning of fossil fuels to catalyze economic growth is responsible for large increases in CO2. In the United States, for example, 38% of the CO2 produced in 2012 came from generating electricity and 32% came from vehicle emissions. The rest came from industrial processes, buildings and other small CO2 production. People also contribute to release of CO2 when they cut down forests for farmland and pasture, as given in The Economist on 2nd November 2014. Sustainable development has many dimensions to it, apart from just ecology and environment. In this module, we discuss various concepts of sustainability emanating from its interdisciplinary nature. Now we will discuss the concept of sustainability. Sustainability translates into the ethical concern for future generations and the need to incorporate this concern into current planning and decision making of economic activities. The concern for future generation affects the use of environmental resources in current production and also the current decision making process. There are various parameters through which sustainability issues can be comprehended, and one of them is through our understanding of different consumption patterns. Utility functions where consumption is the only argument and where utility increases with consumption is a standard proposition to address intertemporal distribution issues. The idea of sustainability as non-declining consumption is the concept of sustainability that is most widely used in economic analysis. However, constant consumption for indefinite time period into the future at any rate other than zero, satisfying various constraints of social welfare maximization problem might not be sufficient to explain and address sustainability issues in totality. The 6 core concepts of sustainability. The following core concepts of sustainability define a sustainable state as where 1. The utility or consumption is non-declining through time. 2. The resources are managed so as to maintain production opportunities for the future. 3. The natural capital stock is non-declining through time. 4. The resources are managed so as to maintain a sustainable yield of resource services. 5. The minimum condition for ecosystem resilience is satisfied through time. 6. The consumption approach to environmental sustainability, where consumption needs to be optimized over time and space. 7. Consensus building and institutional development are considered imperatives for sustainable development. Let us now have a look at the economist's viewpoint on the economic concept of sustainability. A sustainable state is one in which utility or consumption is non-declining through time and in which resources are managed so as to maintain production opportunities for the future. Definitions proposed by various economists in support of these concepts are definitions of sustainability. According to Pezzi, sustainability is defined as non-declining utility of a representative member of society for a millennia into the future, preserving opportunities for future generations as a common sense minimal notion of intergenerational justice. According to Brundtland report, sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. According to Solow, we have no obligation to our successors to bequeath a share of this or that resource. Our obligations refers to generalized productive capacity or even wider to certain standards of consumption or living possibilities over time. According to Jha and Murthy, when we say that a contemporaneous profile of consumption is not sustainable, then it probably means that a switch in consumption either spatially and or over time would improve global welfare, again perceived as a magnitude referring to the indefinite future. Constant consumption and equal opportunities are closely linked in economics. For many economists, the opportunities that matter are consumption opportunities. In this sense, sustainable development is not only about leaving behind stocks of resources for our future generations, but rather the capability to do things we do with those resources. In other words, sustainability involves providing same consumption opportunities, if not any more, to our future generations so that they have the capabilities to do the same things that we do using the current stock of resources. If we cannot bequeath to our successors something that is a substitute for non-renewable resources, then to honor our ethical commitment, we do have an obligation to bequeath a share of the resources that we currently use. The third concept of sustainable state, not declining natural capital, brings us to the differentiation between weak and strong sustainability. Both the perspectives of sustainability, that is weak and strong, define sustainability in form of constant utility or consumption through time. However, they differ in the ways in which the state of constant consumption or utility is realized. As developed in the literature, the weak versus strong sustainability debate makes extensive use of the notion of natural capital. To explain this concept, we first define total stock of capital as sum of human made capital and natural capital. Human made capital consists of physical, that is plant, equipment, buildings and other infrastructure. Human capital, that is stocks of learned skills, and intellectual capital, that is disembodied skills and knowledge like state of technology, whereas the natural capital may refer to all naturally provided stock like water, soil, forest, fisheries, etc. This way of classifying production inputs helps in denoting the economy's production function in summary representative form as Q is equal to F bracket L K N K H, where L represents labor, Kn represents natural capital and Kh human capital. Within this framework, the difference between weak and strong sustainability lies in the extent of the substitution possibilities between Kn and Kh. Proponents of strong sustainability argue that sustainability requires the level of Kn to be non-declining. This conforms to the third core concept of sustainability. Proponents of weak sustainability argue that it requires the sum of Kn and Kh must be non-declining. Sustainability as non-declining Kn assumes that possibilities for substituting Kh for Kn are limited. Ecologist point of view. The fourth and the fifth core concepts of sustainability reflect the viewpoint of ecologists. The fourth core concept is based on the sustainable yields in the economy, and the fifth is based on meeting minimum requirements to uphold resilience of ecosystem. Both the concepts are explained below along with the observations on the general approach to policy making process that is frequently advocated by ecologists. Sustainable yields. Existing stocks of renewable resources like flora and fauna have the potential to grow by the means of natural reproduction. Their stock size in any given period depends on the balance between the rate of their natural growth and the rate of harvest. If in any period the resource harvest exceeds its natural growth, stock size reduces. However, if the harvest is less than natural growth, stock size grows. Stock size of a few renewable resources may fall continuously or even exhaust if the rate at which they are harvested exceeds the rate at which they replenish themselves. If the rate of harvest is the same as the rate of natural growth, stock size remains constant and the resources can be used indefinitely into the future at a constant rate. If for a period of time the stock being harvested remains equal to the amount of net natural growth of resource and these magnitudes remain constant over a sequence of consecutive periods, it is called the steady state harvesting. The constant magnitude being harvested is called the sustainable yield, as in the absence of exogenous stocks, it can be maintained or sustained indefinitely. The concept of sustainable yields run into difficulty in the case of extraction of non-renewable natural resources. For non-renewable resources, natural growth is 0, so that the only sustainable rate of harvest for a non-renewable resource is 0. However, this situation may be partly countered if some proceeds from the economic progress made with the use of non-renewable resources can be used to generate the capacity to provide substitutes for the resource. Let us now discuss the concept of resilience. Concept of resilience is of fundamental importance in ecology. Holling describes resilience as the propensity of an ecosystem to retain its functional and organizational structure following a disturbance without undergoing catastrophic or discontinuous change. Resilient ecosystem does not necessarily imply that all of its component populations remain stable. If the ecosystem continues to function in the same way even after a component population disappearing as a result of disturbance, the ecosystem is said to exhibit resilience. In more technical interpretation, resilience relates to the size of the parameters of the relationship determining ecosystem structure and functions in terms, say, of energy flows through the system. A resilient ecosystem is characterized by parameters that are not affected by shocks to the system. However, some economic activities appear to reduce resilience, but the extent of this cannot be known ex ante. In other words, we can judge the resilience of ecosystem after a disturbance has taken place, but we may not be able to infer ex ante that ecosystem will remain resilient far in future against any shock that comes by. Uncertainty pervades the behavior of ecological systems, and hence one cannot know in advance that whether some system is resilient or not. This is the reason why ecologists give more importance to uncertain nature of ecosystem while conceptualizing the sustainability problem and considering policy responses to it. Ecologists advocated the precautionary principle according to which valid opinions against any action that may have adverse environmental impacts must be presented before the action is permitted. Thus, for approval on the action, it should be necessary to show convincingly that such adverse impacts will not occur. Maintaining the safe minimum standard is another closely related idea wherein actions that may entail irreversible and adverse environmental impact should not be undertaken unless it can be shown that not undertaking the action would give rise to unacceptably large social costs. Consumption priority view. According to Murthy, human activity, anthropogenic, is essentially the cause of environmental degradation. In as much as human activity as is necessary for a minimal standard of living, it is justified. Accordingly, much of degradation that is caused in the process of such human activity is warranted. This lays down the basis for the notion of sustainability. If current economic activity causes degradation of environment beyond such justifiable limits, it compromises the health, standard of living and very existence of future generations. This notion of sustainability does not endorse non-declining consumption through time, which is based on the notion of a continuous increase in the level of consumption. The alternative though in this approach is that sustainability is a problem of optimization and not the sustenance of a certain level of consumption. This can be achieved by redistribution of consumption across time and space. It does not rule out increase in consumption in repressed economies. It does not rule out suppression of consumption in such economies where it is excessive. In this sense, non-declining consumption is not desirable in any absolute sense. This new notion of sustainability is not based on natural resource economics, nor is it based on neoclassical economics. It is also not based exclusively on social discount rate. It does not treat technology and production as the basis of sustainability. The level and distribution of consumption is the purported basis of the new notion of sustainability. Socio-political viewpoint. The sixth core concept of sustainability puts in place consensus building and institutional development as vital components in the discussion of sustainability. Although economists and ecologists do recognize that sustainability issues entail both socio-political and cultural dimensions, this sort of view of sustainability is found mainly in the writings of political scientists and sociologists. This view lays primary focus on developing processes to ensure sustainable development rather than looking at outcomes or constraints. Some important definitions of sustainability justifying this viewpoint were proposed by de Graaf et al. In 1996, that is, development of a socio-environmental system with a high potential for continuity because it is kept within economic, social, cultural, ecological and physical constraint. It is kept within economic, social, cultural, ecological and physical constraints, and development on which the people involved had reached consensus. For many years, it was thought that the eradication of poverty required well-designed development programs that were largely independent of considerations relating to natural environment. But perspectives have changed post 1970s. During the 1970s, a concern for sustainability took form of the international political agenda as was widely discussed in series of international conferences. The common feature of these debates was the interrelationship between poverty, socio-economic and cultural development and the state of natural environment. It has now become difficult to separate environmental objectives from other social political objectives, as their interdependence cannot be ignored. Rather, such interdependence is seen as both pervasive and complex. Perhaps the 1987 report of World Commission on Environment and Development, popularly known as Brundtland Report, set the agenda for much of the subsequent discussion of sustainability with the institutional dimension. In political terms, the Brundtland Report was an influential piece of work which highlighted that sustainability problems are set in the framework of economy environment interdependence. Thus, according to Brundtland Report, environment and development are not separate challenges, they are inexorably linked. Development cannot subsist on a deteriorating environmental base. The environment cannot be protected when growth leaves out of account the cost of environmental protection. The Brundtland Report simply urges that national governments merge environmental and other considerations in their decision making, as conventional approaches to the sustainability issues may not be sufficient. Though the Brundtland Report stressed upon economic systems with environmental dimensions, the proponents of institution and consensus building consider cultural development, political will and feasibility as additional core components of sustainability. In proposing a new strategy, Vidya et al. Urged that one must not view the attainment of sustainability as simply a technical problem. Necessary and sufficient conditions for sustainability cannot represent the problem comprehensively in the presence of fundamental limits to our ability to know the consequences of human behavior. Consensus building should be attempted through negotiations. The notion of negotiation that Vidya et al. Had in mind was very broad, referring to an institutional process of social choice that involves people as widely as possible and involves a process of trade-offs in which all benefits from the avoidance of environmental disturbances. According to Vidya et al., research should be focused on the structure and management of these negotiations and on the supply of relevant information about avertable problems, steerable development. Let us now summarize what we have learned in this module. The sustainability from economic perspective is constant or non-declining consumption or utility, whereas ecologists are more concerned about properties of biosphere such as resilience and maintaining healthy equilibrium between man-made and natural processes. Ecologists' perspective is similar to the idea strong sustainability, whereas economists are drawn towards the concept of weak sustainability. However, one must also note that these concepts fall somewhat short in explicitly specifying the duration of time over which sustainability is to operate. If the idea of sustainability is to influence the policymakers, it must lay focus on the time horizon in which the state of sustainability can be reproduced in perpetuity.